Now, with virtual networks, there's one question that's important to understand is, given these abstractions, where do you want the virtual network functionality to reside? And there are two major approaches here. One is to have the virtual network at the endpoints themselves. So you can have virtual network being emulated on a virtual machine or a physical machine that's running an operating system that's basically the sender and the receiver of your messages in your typical network. Or you can also have virtualization in the fabric, in the network fabric itself, in the routers and switches. So for example, in a VPN, going back to the example a couple of slides ago, you can establish a VPN on the endpoints themselves and have, assuming that you have no control over the network fabric whatsoever. So it's possible to set up a VPN such that software at the endpoints will take care of, again, intercepting a message, encrypting, encapsulating, and sending over a physical link using a different protocol. So this is a process that's known as tunneling, and VPNs can be done with end-to-end tunneling running on end resources, or they can also be done with VPN gateways in the middle. So here's a typical example of VPN where you have two sites connected by VPN gateways. Here the circles in the darker blue, and machines on these sites can send messages over the public internet with privacy by encrypting the payload of these messages. So if a light blue machine on the left sends a message to a light blue machine on the right, before the message goes to the public internet, it is encrypted by the VPN gateway, and it's put as an inner datagram, that message, in a header of a message that goes through the public network, let's say TCP or UDP. It's received by the gateway on the other side, where it's decrypted and decapsulated and sent. Another example, virtualization in the context of VLANs, where you may not have any software in the endpoints, and they still send and receive messages, but now the process of deciding how to virtualize the network is done, for example, at the switches in a local area network that has VLAN. And in a VLAN, you have a simple approach of partitioning the network into multiple segments, multiple virtual networks. So the job that is done to deal with these messages that are sent and received in a virtual network are done by the switches, and it's a simple process of receiving a message, matching what is the tag, what is the VLAN that this message is associated with, and sending to the appropriate port depending on the VLAN tag. Now here the assumption is that the fabric itself is under control, and there's virtualization software running on the VLAN switches in this example. So this is important to understand because we're going to cover virtual networks that may work at these different points, the endpoints or the fabric itself. And another question that's important in the context of virtual networking and abstractions for virtualization is at which layer do you perform the abstraction? And networks are heavily layered, and there are several models for layering. One well-known model is the OC model, which has several layers, but if you look at the two major layers where virtual networks are typically applied, either on the data link layer or the layer 2, which handles messaging between devices connected by a link, for example, Ethernet, and layer 3, which handles messaging across multiple links. So, for example, an IP network where you send messages that may cross multiple routers and switches along the way. Layers 4 and up, the end-to-end layers where you have transport, session, presentation, application, you have application layer overlays at that point, but typically virtual networks will focus either on layer 2 and typically on Ethernet, or layer 3 and typically on IP, Internet Protocol. So we're going to focus the discussion in the next units on networks that support Ethernet and IP. Layer 2 virtual networks have the benefit of supporting all protocols that are layer on top of the data link layer. So that includes IP, but it's not restricted to IP. So it supports simpler integration with a variety of protocols that layer on top of Ethernet, for example. One major downside of layer 2 virtual networks is you have to worry about broadcast traffic. There are several messages in data link layer that are based on broadcast, and when you have devices distributed across wide area networks, the broadcast can be a problem to support efficiently. Layer 3 virtual networks typically again focus on the Internet Protocol IP and then support all protocols that are layered on top of IP, TCP, UDP, for example. It's sufficient to handle most applications. In some cases you have to support a little bit of the functionality that you would expect from a layer 2 network, for example, address resolution protocol. But essentially these are tied to the Internet Protocol, which makes them less generic than a layer 2 VM. But it's a compromise that in many cases is sufficient. There are many applications that work well if provided with the layer 3 virtual network, because they are basically applications written on top of TCP IP, for example. So in the IPOP virtual network, we're going to describe how it does layer 3 virtual networks, but before we get to that, in the next unit we're going to cover some of the virtual networks that work within the context of a single cloud provider.